So, I want to welcome John Abram, who's a principal with HBA Specto. And HBA stands for Hunt, Brownlee, Abrams. I just discovered that. Which has been around for about a dozen years, and he's a principal there, and he's also principal developer of the PICAS land use integrated transportation model, which I know some of you know about. People were in my room the other day talking about these models. And so he's going to talk to you about integrated land use transportation model and throwing a little bit of information about what he's doing with the ARC folks. So welcome, we've got 3 folks from ARC here today as well. I remember when we came down with Doug Hunt, what was it, 3 years ago, 4 years ago, and was just starting to work with you, and they were asking me about the freight parts of the model, and I said, well, I've known Doug for 35 years. So they've been doing a lot of this, and I got to say, when I get asked who should they contact about doing land use transportation modeling groups, I give them the name of these guys. I said they're always in my top 3. I'll not tell you who the other 2 are, but these are the best. These are the best guys.
They're always number 3.
These are the best guys. They're always number 1, and they haven't paid me back once yet. But they do a really terrific job at land use transportation modeling with bringing in all, as you'll see, a lot of the latest stuff, microsimulation, agent-based modeling, input-out, starting from an input-output base, and I shouldn't talk about it. Let's get John up here and have him tell you all about it. Welcome, John.
So I decided to try to do this presentation in 2 parts, one about PICAS in general as a modeling framework, and one about the work we're doing in Atlanta with the ARC. PICAS is a spatial economic model used for forecasting and policy analysis. So the first thing we sometimes like to cover is how we divide up space, the area, the land in the world. So we actually have different levels of geography for PICAS. Parts of it work at a small area of a parcel or a grid cell, depending on the data that's available. We either put a grid over all of the land in the region, or we use the cadastral data as a starting point. For the very large parcels that, the 640-acre parcels that haven't been divided yet, that's not enough detail, so we grid them. So sometimes it's a hybrid of grids and parcels. And then we have the transportation analysis zones, which are being used by the travel demand model, because PICAS is an integrated model that works with the travel demand model to do a forecast and a policy analysis, so we have to work with the transport analysis zones. PICAS doesn't do too much at the transport analysis zones. We really work with a larger area, usually 2 or 3 TAZs at once, depending on, we call them land use zones, but they're really big enough so that we can represent things like average prices for labor, or average prices for space, or so we can represent things with averages. Whereas if you're too small an area, an average of 2 or 3 observations doesn't really mean anything. So that's how we treat space in the model, but it's a forecasting model that runs through time. So this is how we treat time, where we step through time a year at a time, year by year, and we run these different components. The PICAS components are actually these middle components. So if PICAS doesn't stand by itself, it has to work with 2 other things. A transport model, whose job it is to predict the difficulty of traveling between zones, basically. And so that, and then an aggregate economic model that we're in Atlanta using REMI for, which is used to understand the overall economic conditions and forecast the overall economic conditions in the region. So that's sort of how we treat space and time. So that's just a little bit of a way to sort of set some of the context of how things are treated. So I used to go around years ago saying that PICAS is this really complicated, cool, powerful, fantastic framework, and I realized that wasn't getting any traction. So then we said, well, no, it's really simple, we said. It doesn't do too much. It really does 5 simple things. So we're really modeling choices people are making that we think are important, and the top 3 are choices made by households and businesses. We model their location decisions in terms of where they're going to looking where households are, not just asking about when he moved and why he moved. So these are locations decisions about where you choose your home, or for businesses where you're choosing your business location. And the second one is something we grabbed from input-output modeling. It's called the technology choice, or for households sometimes we call it the lifestyle choice. It's really a vector of what you're going to, the quantities of interactions you're going to have. So what you're going to make and use. So for households, if you send your kids to a private school, you've chosen to consume a certain amount of private schooling. If you've taken a job as a professional engineer, then you've chosen to supply and sell a certain portion of labor of a certain type. And if you're a business that's making pipelines, you've chosen to purchase a bunch of steel and sell a bunch of pipelines. So really we represent your whole life in terms of your interactions and what you do in terms of quantities of commodities that we call them commodities that you make and use. And that's from input-output economic modeling in terms of showing the relationships, this economic relationships between things. And then we take it spatially and we say, okay, well, if you're going to have these interactions in the economy, where are you going to go to do these interactions? Where are you going to choose to sell your labor? Where are you going to choose to buy your education? Where are you going to choose to sell your pipelines? And so those are the three choices that we represent for the businesses and households. And then we represent developers separately. These are the people who construct the city that we live in. They build the buildings, and their choices, we actually go through parcel by parcel. We only do two choices for each parcel: what to build, whether to build. I guess it's three real well. Whether to build anything, what to build, and how much to build for each parcel. So we try to, simplify the entire spatial economic system into this sort of thing. So we're going to talk about the space development module first, which is the part that takes the parcel database and moves it forward year by year, representing the construction and demolition and stuff that occurs. We call it SD, just as a jargon term. So we really tried to, at one point, we had the equations set up that made sense from an operational perspective, but we went back to first principles and to random utility theory and set it up with a single utility function where the utility on the left, let's see if we get that, things that come up right. The utility on the left is really a function of the building size, how big of a building you're going to build, and then how much land it's on it. And so we are saying, well, when you build a building as a developer, what you're looking at is the future rent stream, and you're comparing it to the construction cost. So really that first term, the THJP, is a forecast of the rent that you're going to get from the building minus the amortization of the construction cost. Because it's a return on investment calculation, really, where you're going to build something on a piece of land, and you're looking at a 30-year rent stream, and you want that return from your rent to be greater than the cost of construction. And then we have to add in some random terms, because otherwise, it's not random utility theory and everything. It's too blocky and stuff. We need to be more random like in real city. Because there's risk and uncertainty in development decisions. It's not a certain thing that any development's going to make money. There's randomness. The more likely it is to make money, the more likely it is that somebody's going to take the risk of it. So we end up with this, the way we specify those random terms and stuff, we end up with nesting structure basically like this, where for each parcel, you can do the node change with, well over 90% of parcels every year. Nothing happens, nothing changes to them. Or you can build the new space, but if you're going to build the new space, you have to choose a type, and you have to choose how big of a building to build. But we also have some other things that you can do. You can add space to the existing building, you can renovate the existing building, you can demolish it and leave vacant, or you can let it go derelict because you don't want to build something, but you're not getting appropriate rent from the existing building. So then, got kind of complicated in math. We had to do, well, because this is a continuous, people don't use these very often, but this part here is a continuous logic model. So the choice of how much space is based on continuous random utility theory, so then we have to do some integration over things. If you're interested, that's all the equations. So then in the end, we have, this is an example, just a picture of the parcel database that we're using in the Sacramento model, where we go parcel by parcel, we get to that parcel in the middle that the arrow points to, and we make a decision for it. And you end up at the end of a 30-year simulation or whatever, you can plot the individual simulated developments. Now, of course, we're not trying to really predict whether somebody's going to build a new strip mall on one corner versus the other corner of the street, right? So we're really looking at averages and patterns. We're using a microsimulation in the same way when you're doing a travel demand model and activity-based or microsimulation-based travel demand model, you simulate individual trips for individual households, but you're not pretending that you can predict what your future grandchildren are going to do in 2050 on a Tuesday. So in the same way, we're not trying to predict what happens on an individual parcel in Atlanta. We're just trying to use a simulation procedure to come up with patterns that are realistic and accurate on the zonal level when you aggregate it up, and policy sensitive. So we end up aggregating up to the TAZs so that we can feed results into the travel model and continue the simulation forward. We end up storing all of SD's stuff into a spatial database, which has these sort of components. The stuff, the sort of urn-shaped bubble there is the spatial information. So we have the parcels at the top, but then we have 4 other GIS layers. There's the zoning, which is the permissions that the local government, so this is our major policy input for SD, the permissions that the governments use to control the density and type of buildings that are allowed on a parcel. And those zoning permissions are by different space types. We have space types as representing building types really. And then we have some cost layers because bedrock and sewer and things like extending services can add a lot to the cost and stop certain parcels from developing. Then we have the fee layers because some jurisdictions are very unfriendly to developments. They use a fee or some sort of red tape process to discourage development. And then we have what's called the local effect distances. This is our way of, when I get to AA, you'll see it works really at a zonal level, but we really want to represent parcels individually in terms of what some parcels are good for something, some parcels are bad for other things. So, for instance, the parcels right next to an arterial road, in a zone will have a local effect distance, which makes them more attractive for commercial use because of the visibility of traffic. But it'll have a local effect down here that makes it less attractive for residential use because people want to live next to it. So this allows us to get much more realistic patterns of parcel development. So that's what I just said, really. We also do a thing where years ago, where's my slide? That took so long. Really, we have a density shaping function because if you're just looking at parcels and overall average cost per square foot and stuff, if you're going to build anything on a parcel, it looks like you should build at the maximum density allowed because that's you get the most rent and for the unit of land. But we don't see that in reality, and there's a number of reasons we don't see it. One is because if you're trying to push the density up, you have to do things like concrete structure, underground parking, so there's supply side construction costs, things that kick in at different density. But also on the demand side, people like their yards as well as their houses. So anyway, so we end up with these, so we can control not just the location of development, but also the density of development. Why these graphs take so long to load? is on my screen is still advancing. Just trying to remember what the next slide is.
Trying to visualize it. Maybe escape that and just put them in the non-projected view.
I'm starting to make noises. It moved. Wait. Okay, I can see the next slide on my screen. Maybe it'll show up on your screen soon. I think I must have really complicated these graphs. Must have been from Excel. Okay, so one of the things that we've been wrestling with just today at ARC is that you know, everybody thinks they have great parcel data, and ARC actually does have great parcel data, but it doesn't. We can't use it really directly in the modeling, really for four reasons, I think. One is because it's inaccurate. You know, your assessors, you'd think that because they're building tax records off it, that they actually know when the buildings are. They don't. It's wrong. But even when it's right, sometimes, you know, census also makes mistakes. So census puts houses, or census puts households in the wrong tax sometimes. And so there's houses in places where there's households from census in places where there's no houses in the parcel. So it's inconsistent even if it's right. And the categories, you know, we design a model, you know, a lot of times we do luxury versus economy dwellings because we don't want the rich people and the poor people to switch. You know, they're just not going to switch places that well because of the type of housing that's there, not because of the size of the housing, but really the quality of the housing. So we have qualitative category variables that we use sometimes. And so anyway, so what we do is we actually build a synthetic parcel coverage layer, which is synthetic built form with buildings of the types that we want, and the quantities that we think are there. And we use the parcel data as much as possible to inform that synthetic built form. So a lot of times it looks exactly like the data that's there, but other times it's not like the same. I'm just going to switch to it. Just try starting. Okay, so that's basically the SD module. So then if we go to the activity allocations module, which we call AA, it represents these three decisions, the ones I was mentioning about the location decision, your lifestyle or your technology choice, and your interaction with locations. So we actually, this is one where we actually took some time to think about the utility of that bundle of choices. So if you're choosing a location to L, there's a certain attractiveness of the zone that you're locating in. Maybe it's got nice trees or something that's not really like a spatial economy model. And then there's some, you know, certain things, like the type of house you're in would be in here because the technology choices, the type of occupation you have, whether to send your children to private school, that's in here, this choice of technology. But, so these are sort of the setup to the utility function, but really here's the utility function where we take the quantity of the things you're buying and selling, and we multiply it by this these are accessibility measures, really, which are given your location L, someplace that you're going to E to sell your neighbor or buy your education, buy your retail goods or whatever. This is the accessibility measure of how easy it is to do that, but it includes prices, so it includes, you know, if you're close to a lot of high-paying jobs, well, that's good. If you're, you know, so it's prices and distance and size sort of terms that show up in there. So the more you, the alpha term is the more you interact with a certain commodity, the more important it is to your life. You know, if you don't buy any cigarettes, well, you don't care how expensive they are or how hard it is to get. But if you buy a lot of cigarettes, then and so anyway, so we build up these utility functions, and then by making certain assumptions of the error terms, you know, blah blah blah, random utility query, blah blah blah, you end up with a nesting structure where you have your selling allocations here. So you have a choice of where to go and buy and sell things. So this is all your flow matrices that are the origin choice and the destination choice for all these flows end up here in these buying and selling allocations. And we take the composite utilities of those and we use what's called an additive logic model, additive nested logic model, really, because we have all these commodities we have to add together and nest to get the technology choice, which we then take the logs on that, which ends up into the top level utility function for the whole bundle that you've chosen. So we use that, then, and then here's how it sort of operationalizes in the software system, where if you have people producing certain things here and other people consuming things there, and the goods, this is why it's called the PICAS production exchange consumption allocation system, because stuff is produced in one zone, it gets sold to an exchange zone where it gets consumed by the person who's using it. And so all the interactions work this way, and we actually adjust the prices in the exchange zones to clear the markets for a short period of time.
How do you handle non-market goods, like I want to be near a lake, I want to be near a park, and I want to be in a good public school district, not that I'm buying private school?
Two ways. One is that a lot of that actually ends up in the VLA, which is the zonal constant for the zone for a certain activity. But the commodities don't have to all be market economies that exchange with a monetary price. For instance, we have greenhouse gases as a commodity, which, you know, through a pollution tax, you could put a price on it, but right now there is not a price. So, but a lot of that stuff ends up in, it depends on the design of the model. If it's stuff that we want to track the flow of, we would end up trying to put it in as the right side, but if it's stuff that's really more of a zonal characteristic, we end up putting it in that left side. So we're going through San Diego. In San Diego right now, we're really trying to do a better job of a lot of those things, like crime rates and stuff like that. So then we have these sort of interactions where, so now you can see that the REMI model, which is what we're using outlined at the top there, comes up with these activity totals. The allocations module solves the short-term equilibrium to come up with the flows of all the commodities and the prices, the rents for all the space. And so that's the interaction between those two, is that if a place becomes desirable because it's accessible for certain commodities, the rents will end up increasing for the space in that zone, and then that rent flows into the space development model, and so space development model should build more buildings in the zones where the rents increase, and less buildings in places where the rents increase. So over time, then, we get buildings being built in places that are more desirable for whatever purposes we have. I guess, you know, what we don't have is like a list of our activities and commodities. We tend to divide households into the usual sort of categories based on size and income. Not race usually, because that's just too politically. And we divide businesses into house categories based on industries. But for the interactions, for labor, we actually use occupations, not industry, because a lawyer working for a retailer is kind of the same as a lawyer working for an education institution or manufacturing, whatever. So we don't want to use manufacturing and retail education to represent the labor market, we actually want to use occupations, so what people do for a living. Okay, so that's all I really had on the framework. Some stuff's going to come be a little more apparent as I go through the ARC examples. So maybe I'll pause for a minute, see if there's any questions on the theory.
I would just, sort of as a follow-up, you explained how these sorts of notions are in the model, but you also alluded to the fact that a lot of regions don't really have that great of data. So even though the model has the ability to model these types of decisions that people are actually making, how often do you find it in the regions that you've worked with that they have data that it is really coming anywhere close to representing the way that people actually make these choices?
Well, I shouldn't say that there's actually data problems. It's not in the United States because their census is so great, right? So we have, through the PUMs and through the ACS PUMs and through the census tract data, we can get at the, really at the tract level, a good idea of the housing that's there. And we get an idea of the people that are there. And Implan, the company called Implan, they take the national technical coefficients about the economic interactions and they apply them to each county in the United States. So they provide a very valuable service of sort of applying national data to each county, so you can get a really good idea of the economic picture for just a few $100 for each county. There's other ways to do that too. Implant's a convenient way to do it.
They also have the social accounting.
Yeah, so you end up with a social accounting matrix for any group of counties in the United States. And on the map data from the employment insurance people give you a pretty good idea of the where the jobs are and where people work and live. PUMS also has occupation, doesn't have occupation. PUMS does have occupation, but they don't necessarily report it as industry. So we actually get a pretty good, actually in the United States, it's actually pretty easy to get a good picture of how the overall spatial economy is working. What you don't get is which parcels are actually have which types of buildings. So that's why we end up using the floor space synthesizer. You know, we have to rely on it. We always have to rely on it. We've learned that we always have to use it because there's always some inconsistency problem. But the less data we have on the land coverage, the more we
I just wonder at our ability to predict things like, the resurgence of the city and the fact that, there are a lot of people sort of looking to move back in, and these seem like things that it's really hard for a land use model to actually predict.
Yeah, well, this gets into the question of sort of the one true forecast versus scenario analysis sort of stuff, ARC is really thinking in a forecasting mode, I would say, right now, because they have to get a certain forecast out by a certain time for a regional transportation plan.
Mm-hmm.
But really, we should be designing our cities to be robust to a lot of different policies. If people decide they want to move more into a certain type of housing, like they're more likely to live in multifamily housing and ride their bikes more, if that's a cultural shift that occurs. I don't think we have any hope of predicting that, but we can try to design a city that functions well if that occurs, or functions well if it doesn't occur as well, right? So we can try to design it, we can pursue policies. So I think we should be running a lot of different scenarios, not just policy scenarios, but also sort of socioeconomic scenarios about different ways how the future might play out and how the city spatially will respond to it in that way. So that's sort of a difference, between a forecasting model and policy and scenario analysis. PICAS tries to be both of those, right?
Okay.
Seems like the zoning would be one of your main policy. Well, certainly that's what both governments think about it. But do you have kind of a, between jurisdictions, kind of a probability of change or ease of change sort of metric that in maybe Clayton County it's very easy to change the zoning, and Roswell it's very tough?
Yeah, we call it zoning, but it's not really zoning, it's more sort of a general plan indication. And we have what we call acknowledged uses, which is really discretionary uses where, if there's enough market forces there's a higher probability that something that's not officially in the plan will be allowed or not. So yeah, we have sort of flexibility in this.
How does the user code those rules?
They are for each, well, for each polygon, I think of this polygon. For each polygon, it's a list of the space types, the FARs, densities that are allowed, and a sort of a penalty measure, which is how easily it's going to be allowed.
So it's a cost measure?
Yeah, it's a cost. It's
Okay.
$1 per square foot kind of penalty measure, which a lot of times isn't monetary, a lot of times it's more sort of renting cost, but we have to monetize it.
And how do you monetize that? Is it,
Well, we've been looking at California. There's a report called the, I'm going to say Rose? Rose? I forget what it's called. But anyways, there are people who, the building industry tries to quantify that a lot of times. What they don't quantify is the delays. Well, they do quantify the cost. They don't quantify the delays. So some stuff, if you apply for a development permit, it can be 5 years before you get it. So you just apply somewhere else. So it's quite difficult to get into the engine. But that's part of the things that it's part of the purpose of how we run the model. Like in San Diego, we run the model. We get high rises showing up in La Jolla, which is where Pebble Beach is, And people say, the planners look at that and they say, well, you can't have high rises in La Jolla. And we look at the zoning and we say, well, you put the zoning into the model. The zoning allows it, So sometimes the model becomes a tool to explore that, and force people to quantify stuff that they already know. So yeah, so you don't, you want to get into a situation, you're running the model, you get the forecasts, you lay them out in front of at least the agency and people you trust, and then you get the feedback, and so that you can get. That's kind of where we are with ARC now. We're running the model, we're looking for, sort of issues with the model. Probably should go on so I can cover. They have this is sort of the, it's because you guys put too much graphics. Yeah. Okay, well, I guess I'll talk about this one until it switches.
Until the other one comes. Yeah.
So we have, the ARC is doing regional forecasting to come up with these control tools. I don't think Colby's doing sort of different scenarios, maybe.
To a certain extent.
And then we do this small area forecasting or land use allocation, which is actually what we have to do for the regional regional transportation plan. What if I just X it? Should I continue on the next one? Just in terms of what we have to do, we actually have to do a major, we're driven towards this major plan update in 2015, 2016. So we're at the stage now where we're actually doing some sort of policy analysis runs, scenario runs. This is the Atlanta model area. It's the 20 county area, which we divided into 78 land use zones. I think it's using more land use zones, but it seems to be working out pretty good at 78. We use a technique that everybody uses in software development now, which is pretty unusual to use in a lot of development. Maybe it's getting more popular. Of course, Springcraft's using it a lot now. But anyways, it's called Agile development, where iterative development, where we actually build something simple that works and then improve it. We try to roll out an improvement every 3 weeks. Not all of those improvements will be sort of ready for use. Maybe every 6 months we'll have a system that's a better system that we can roll out for use. So it's a software development technique to avoid some of the spectacular failures in software development, especially for government procurement contracts where they gave IBM $50 million and nothing at the end of it. So for software development, people have taken on this sort of technique. I was thinking about any sort of software platform has evolved, Microsoft Word, Microsoft Windows, Facebook, any of these platforms, they grow incrementally with more and more functionality. Yeah.
So is Agile development rapid prototyping? Or
Yeah, it's similar. Agile development is more of a jargon term for software now, so there's a certain amount of procedures, standardization of the approach, but yeah, it's really kind of rapid. Yeah.
Are agencies pretty willing to go down that path, and are they willing to say, it's not going to be final when you give it to them the first time?
Yes, I mean, yes and no. It's a matter of trust. We find the longer we work with an agency, the less detail they tend to put into the contracts, because we just know we're just going to do what we can with the funds available, and they're going to have to go along. But at the beginning, the contracting process wants to have certain deliverables at a certain period of time, so we try to under-promise and over-deliver. So yes, I think the agencies are being quite responsive, but the contracting process doesn't match one to one with the Agile development process. So, we're now looking at some. We've integrated with the old four-step model that ARC has, but they're rolling out their new activity-based model this year. So this year we're going to integrate with the new. Blah blah blah. This is some of the stuff we did recently. This is some of the stuff we did recently. Some more stuff we did recently. So here's some scenarios I wanted to show you. We have these three scenarios that we've identified. The W4B scenario is one of the runs we did where we ran all of PICAS through time, the current version of PICAS through time from 2050 or 2040, I forget. 2040 from 2005 is the base year. And then IO1F is that same model but integrated with the travel demand model as it should be, so that the land use patterns are feeding into the transportation model, which assigns the traffic and comes up with new schemes, new indications of travel with this utility, so that the land use market can respond to any congestion or improvements or whatever. And then the NBO one, so we ended up saying, well, let's do one where we don't build any of the improvements we have scheduled for the next 40 years. And let's run that scenario. So no build, really a true no build scenario. So we do these job density maps. Oh yeah, okay, so this is where the households have located between 2005 and 2022. I forgot why we chose 2022. So this is sort of the growth in households in our base case scenario, but this is the growth in jobs. The model still is predicting quite a concentrated growth in jobs. This is actually in the downtown area, sorry. Didn't finish this. But anyways, one of the things we do is comparing scenarios. So this is really the impact of building all this stuff we plan on building. So red is more in the build scenario, this I1F standard scenario, and blue is more households in the no build scenario. So this is just basic urban economics, whereas if you don't provide more transportation, people have to live closer to each other, right? Because you're not allowing them to travel as much, so through the provision of transportation. So you have people choosing to live closer to Atlanta and closer to inside. But we can do look at the buildings that. So that's from AA, that's the people living in the buildings. This is the buildings themselves, so this is actually the construction of single-family buildings. We don't see so much of a pattern, such a strong pattern. Colors have reversed, actually. It doesn't matter because you can't really see a pattern. But here is the multifamily where, let me think about this correctly here. The red is actually more in the no-build scenario. And so we have all this, it's kind of hard to see, but you have all this new sort of Buckhead, North Perimeter, Midtown construction of multifamily. If you don't, and there's actually quite a bit down here as well, right about here.
So that's kind of the Decatur, Emory, Strawberry.
Yeah. So if we don't, so the model's saying that if we don't build all the stuff that we have planned, people are going to have to live in these multifamily homes, which of course planners love, but you'll see later that it's not so
Only
great for the
planners.
citizens. So as a result, we have a lot more households living in we didn't get the context here, but this is sort of all the perimeter here. We end up having a lot more households living within the perimeter if we don't build all of the freeways. Job-wise, it's a little bit more mixed, actually. We have a lot more jobs right downtown and midtown if we don't build all the freeways, but we end up losing quite a few. It's not just the freeways, it's also all the transit improvements. So anyway, so that's kind of the story we get, but this is the story that a lot of people, you know, until they actually have the PICAS model, they don't realize how powerful this is. This is the consumer surplus. Everything's built on random utility theory, so you can take the top level integral of all the choices that people make and come up with a benefit measure. So this is each color band is a different household, or a different category of industry or household. These sort of ones are from the orange down are sort of the household categories. So we see that if we build all the stuff we're planning on building, well, we get this $500 million a year household benefit. It's $500 million annual, I guess, benefit for households. But you get this huge, huge, huge benefit for businesses by providing all that new infrastructure we're planning on building. So now you can see, well, planners might like it if we don't build anything, so that people are forced to live in multifamily around the perimeter, you know, within the perimeter. But you know, really, it's going to hurt our economy a lot if we don't build all this stuff. It's going to hurt our economy by about $2 billion a year by the time we get to 2040. So,
And how do we interpret the stuff that appears to be below the axis?
so these are the industries. I'm assuming they're industries like.
Those are household categories.
They're households. So these are actually household categories that actually are not going to benefit. So benefit from the new infrastructure. And what some of them are quite interesting. Some of them are labor market interactions where if you provide more transportation infrastructure, people from the suburbs can come in and more easily take jobs in central areas. And so that actually means less job opportunities for the people who are living in those central areas. So you actually end up with some people suffering because they have more competition for their jobs. So certain categories of people suffer. So this is where it actually becomes important to interact with Colby's REMI model because the Parks REMI model that Colby Lansman is developing. Because in reality, if we didn't build, in the no-build scenario, if we didn't build all these freeways, there would be less economic growth because it hurts. You know, this is a utility measure. There's $2 billion of utility lost. That means there's going to be less businesses coming in, and we're going to suffer economically. So we have to weigh sort of, you know, we have to properly weigh the fact that we're maybe being more environmentally friendly and forcing people into multifamily places where people should live against the fact that we might lose a whole bunch of business unless we can figure out something to do here.
What would the cost of this benefit be?
Sorry?
What's the cost of this benefit?
Oh, you mean the cost of the construction?
Yeah, because
It was a lot. I forget.
I think our plan was something along the lines of 60 billion.
Yeah, it's actually
Yeah,
more
over
like
the entire
so
period.
if we add up all these numbers,
right.
only to 24.
Yeah, these are increments.
It's actually
not
less than the cost of the infrastructure. Don't say it too loud.
Can I ask Jim a question?
Yeah, try. Yeah.
You remember the analysis that we did for the T-Splosh,
Yeah.
which shows lots of positive benefits for that, whatever the number was, $8 billion, whatever it was,
Right.
investment.
Right.
But what John just said seemed to be counter to that for this set of investments.
No, these are positive benefits for this set of investments.
Yeah, I think.
But
It's
No,
not,
I said
it's
not
not
net of
positive
the
for
cost.
every
Not out of
category.
the cost, you're right. Well, it depends how far, if you kept going, you know, past 2040, right?
right, you keep adding those in later
Because the
space.
infrastructure that we built in 2032 is gonna last for more than
That's
8
that's
years.
true, yeah.
Yeah, that was my next
Because
question.
yeah, to get positive benefits for a lot of the T-SPOS investments, we had to run a longer period of time to allow those benefits to accrue. You know, they're not gonna pay for themselves within a very compartmentalized period of time. That's true.
But I think, you know, so what happened, I mean, the way this should all work out is we run a scenario like this and we say, shoot, you know, Jesus, doesn't look like these transportation investments are quite worth their salt. Maybe we should support it with zoning or something, or maybe we should, you know, maybe we should find, maybe there's some of these that we can cut and some other ones we can add in, you know, maybe we should, you know, maybe it's not just about building the transportation, maybe we need to think holistically about the whole evolution of the land. And so that's sort of the way the conversation should go, is we come up with some scenario, we run it, and we go, uh-oh, it's not quite what I have in mind. And we have this internal discussion internal to the agency first, before we ever go to, and then, you know, and by the time, I have a philosophy that one of the best things you can do with a model of any sort is kill a bunch of bad ideas. So, you know, there's always somebody, a politician or a bureaucrat or somebody's, you know, saying, hey, let's do this. And, you know, let's run it in the model and let's show that it's a really dumb idea before it ever gets into the public decision-making round. So that by the time we get to the public, the public's deciding between good ideas, right? We have this good idea, it's a good vision for the future, you know, it's not shared by everybody, but it's a good vision. You know? And then we have this other idea, well, here's another scenario that's also a good vision, but it's a different good vision. And the public is allowed to decide between two good ideas. It doesn't have to, the public's not troubled with burdened with the responsibility of rejecting dumb ideas, because we've already rejected, you know, we've already fine-tuned the ideas to make them good before we bring them on.
It's more knowledge at a very,
Yeah, exactly. And that's kind of what we're trying to do with this sort of graph is, you know, is make sure that our ideas are good before we get them to the decision-making process.
Let me ask one more question about the below the axis housing types. Can they be tied back to particular stakeholder groups, ethnic groups, income groups?
Yeah, income and size, we don't have ethnicity or race.
Even in Atlanta, don't do the ethnic, because I mean, when I first moved here from California, one of the things that struck me was that that the different ethnic populations were segregated also by income here,
Yeah.
whereas that was not my experience in California.
Yeah, it's a tough decision. Just, you know, you don't want the whole conversation to be about race and ethnicity, you want to be about benefits.
Is this account, I think I know the answer, but this doesn't adjust for air quality benefits or?
No, I mean, air quality is a big deal in the United States because your transportation funding is contingent upon showing air quality. So it becomes, it's not, it drives the timeline. The air quality conformity analysis drives the timeline, but it's not what this is.
it's not integrated specifically in PECAS.
Right.
And it's not the tail wagging the dog that it used to be.
Right. So we're ahead of the curve a little bit, you know, because we don't have to do conformity analysis to 2016, so sometimes use the model to do something. Well, I finished almost on time.
Okay.
Oh wait, I have conclusions. Oh, I did want to mention a couple of things. Okay, so AA does zonal level top-down allocations. We'd actually like to replace it over time in the research environment. We'd like to replace it with a micro-simulation of individual households choosing individual dwellings, individual businesses choosing individual locations instead of allocating down. We don't tend to collect a lot of data specifically for this model, and there's a lot of data out there, but it would be better if we could, you know, now that we have sort of a history of using these models. This is what we're sort of going to do in ARC. I had some screenshots of some of our software tools.
So the agent-based model is the travel demand factor simulation model?
Well, we'd probably like to use the same synthetic population, but in AA, the households are choosing where to live and where to work, really, and maybe making some of the other destination choices. And the businesses are looking where to locate, but then the actual real detailed travel choices. Well, I'd like to integrate them a lot more tightly, first of all. It's like just two synthetic simulations that use the same population.
Well, I had a comment, maybe a question, maybe the ARC, because I like the fact that you're running a model and you're playing with it rather than changing it. So is this level, it's a pretty high level of interaction between you and the model? How much interaction? Because, I don't know the model is this sophisticated, complex that you can just run.
Yeah.
So I'm wondering, and I know from talking to your colleague Doug Hunt, we've had lots of conversations about the model, the modeler, and what you can and can't assume and what you need to do. And you need to bring a lot of knowledge to
There's a huge learning curve for us.
to a model like this because it's going to throw up a lot of non-intuitive results.
Exactly.
In fact, that's why you do it, because if you just go with your intuition, you're going to mess up. It's
Yeah.
too complicated.
Yeah, that's right. That's the other, the other reason to do modeling is because, well, if it was just common sense.
Right.
So there are something, our plan is in the future, we provide this model for many people to run. We build a model is ready to run for scenario testing, like a policy stuff, like a junior layer policy. If the user has specific, project or big thing big enough to be responded by this project, we just, we can provide this one and users can load their data and run the PICAS. Interactive with the travel demand model, see the difference, see the, the effects of the project. So that's in the future, we will provide this kind of platform.
But I guess the other thing that I think follows from that is that, people are going to be able to build these kind of maps. We actually have a web interface to show, how much employment changes over time. We use a bar graphs, each bar is a year. So it's pretty easy with the web, with the way we've done user interfaces, to show what happened in the model. The more complicated thing, which we're trying to enable ARC staff and come up with better graphs and outputs, is why it happened. Like the example of, well, some of the low-income household types are better off and we don't build the freeway.
Right.
So, why? Geez, why? Well, something. It could be their housing, could be their jobs. Those are the big things, housing and jobs. But it could be education, could be that the retail's all left and they have to travel a lot of distance to get their groceries because the retail got pushed out by office or something. So it gets quite complicated, and that's where Geraldine and I are trying to sort of come up with better tools to enable investigating the why. So seeing the what is actually quite easy. Yeah.
I don't know if this question goes for you or for ARC, but has there kind of been any thought to sort of do this backwards, sort of input what we want Atlanta to look like in 2040 and spit out, okay, these are the projects or these are something kind of along those lines, as opposed to just throwing in inputs and seeing what happens. Does that make sense?
Yeah, we have if somebody already has a plan, we put it in as a set of constraints. The model then generates the zonal constants, which we usually try to describe with things like prime statistics or school qualities or those sorts of things. But the model then comes up with a string of zonal constants for each activity, so for each type of household, for each industry. And if those are changing dramatically, then that's an indication that that's unlikely to happen by itself. And so then you would have to go in and kind of going from that to the, if the constants are going up in places where you're expecting people to live, well, it means you're going to have to do something to force them, to get them to live there. It's not going to happen. I'm saying it's not going to happen by itself.
Okay.
So yes, in a way, but then to take that to the policies is a lot.
Not specifically using PECAS, we had a pretty significant scenario planning exercise as part of our last conforming plan that didn't use PECAS as a tool, but used bridge software that we were using for small area allocation So we always have, as a part of our plan development process, had that start and the end process. But yet, that we're not really conceiving of using this as much for that immediately. It's more of a forecast development.
Yeah. But if somebody has a preliminary plan, this is a tool to sort
You
of
can't-
show whether it's realistic or not.
Right,
Yeah.
right.
Yeah, I think we better wind it up. It looks like someone wants it for lunch. So let's thank John very much.